show you our circuit. So we've got the function generator input coming from the digilant, and the positive end of that is going into R1 and RS. So RS is this red one, and then R1 is here. So if you go across R1, you get the point B, which is on the left side of the Wheatstone bridge, and if you go through RS, you're on the right side of the Wheatstone bridge, which is point C. So this is R3, which is like, it's the actual Wheatstone bridge, and the resistance of this one is super high to kind of simulate that infinite resistance in between points B and point C. And you can see that this point C feeds into the potentiometer, which goes to ground, and point B feeds into resistor 2, which also goes in the ground, and ground is connected to the negative end of the function generator and the ground input from the digilant. So now Anais is going to describe our waveforms. Here she is.
Hi. So this is the waveforms. In yellow we have the channel 1 and in blue the channel 2. As both voltage are very close, the curves are almost the same, and in red we have the differences, the peak-to-peak the differences between both channel voltage. So we see that it's almost zero. Here we have the value, which is oscillating around 0.03, which is volts, which is very small. And if we turn the screw of the potentiometer this way, we can just see that it's gonna change and increase. It increases the voltage differences, while decreasing the channel voltage as well, on which change the differences.
Can you show it again?
Yeah. So yeah.
So now it's gigantic.
Okay.
And then to get back to the minimum, we just screw it back the other way. Like that. So now we're getting it back down to the minimal voltage, as you can see.
The curves reach the almost zero peak-to-peak amplitude.
And now I will explain exactly why we need to find the minimal value. So you can see here, the difference is equal to this expression here, which we derived in class. So ideally, we want this difference to be 0. So then when you divide both sides by Vs, Vs goes away, and you're left with this expression here. R2 over the sum of the resistors on the left side is equal to R potentiometer over the sum of the resistors on the right side. So this is essentially a ratio between the bottom resistors and the sum of the resistors, and you can interchange that with the ones on the top as well, but this ratio allows for a 0 voltage difference between points B and point C.